Welcome back to the channel and to our turbo diesel Chevy S10 project. Well, sort of. The engine we selected is not turbocharged, but it will be as this project evolves. So no worries, this engine will get a turbo. So I'm Jimbo and I'll be your narrator, parts fabricator, and engineer in today's video. Just like I was in the previous 204 videos that I published on YouTube. I'm human and I'm not some sort of AI contraption. Actually, I'm somewhat flattered that some people think I'm an AI thingy, although it is quite a stretch. But people perceive things differently, I guess. Nope, it's just me and sometimes a cameraman having some fun in the garage building stuff nobody else will. Anyway, in the previous video, we used a reasonably priced kit that was filled with many shiny parts, and that allowed us to attach the rear-wheel drive transmission from this 1989 Chevy S10 to the 1.6 liter normally aspirated Volkswagen diesel engine. This project is going to start off with the smaller displacement Volkswagen engine and will eventually graduate to the more powerful Volkswagen TDI engine. The good news is, about 90% of what we fabricate will transfer between the engines. So the challenges that we have trying to fit our current engine into the Chevy will be about the same with the TDI engine, but we'll have most of the parts. So in the previous video, we managed to slip the engine into the Chevy and connect the transmission mount. Basically, that means this is where the engine's going to sit in the chassis. The challenge today is to fabricate the motor mount so this engine is firmly attached to the truck. At that point, then we can focus on all the little details to get this truck back on the road as soon as possible. In order to get this engine to fit in the limited space that we have, we need to be mindful of a lot of stuff, and every decision we make will affect something either in a good way or a bad way. Let's look at what we have to deal with. The shifter, the oil filter, the intake manifold, the oil pan, the dipstick, the drive shaft, the heater box, the coolant bypass hose, the exhaust manifold, and the thermostat water neck, and possibly a few more. These are the major players, and they all need space to exist in order for the truck to go down the road. Now, in one way or another, either directly or indirectly, they all come in conflict with the suspension crossmember and the firewall. It's going to be a challenge to get all this stuff to fit, but it will. Nothing is impossible with a grinder and a welder. So this guy is the biggest problem. You see, the oil pan on this engine hits the suspension crossmember, and if possible, I don't want to modify the crossmember. That's a big chunk of steel, and it was engineered to handle the suspension loads, and that's the last thing I want to start cutting up willy-nilly. So whatever we do, it's going to involve modifying the oil pan, that's for sure. The suspension crossmember is kinda off limits for now. So right off the bat, let's establish a rule that we cannot break, and the engine can't move forward or reverse more than a ½ inch. If we tried to move the engine far enough to clear the crossmember, then the shifter on the transmission would be under the dashboard. Of course, the drive shaft would also fall out of the transmission. Anyway, the slip joint on the drive shaft will afford us a little wiggle room, but not much. The position of the engine is more or less locked in, and we have to find a way to make the oil pan work. Now, a lot of folks suggested that I look at possibly using an oil pan from a Volkswagen Dasher or a Volkswagen Golf and a few Audi products. The good news is those cars actually use a different oil pan. The bad news is the deepest part of the sump would land directly over the crossmember, and using one of those pans would make our situation a lot worse. I actually spent a long time sorting through various Volkswagen and Audi oil pans, including transporter pans, and unfortunately there's nothing available to help our situation. Also, since the pan is asymmetrical, we can't install it backwards on the engine. Ultimately, we're going to have to modify the existing oil pan to gain the clearance we need, and doing that will likely lower the volume of oil that we can hold. So we're going to have to modify the pan even more for a deeper sump to gain back the oil volume that we're going to lose. Now, this project requires a fair bit of welding of this, that, and the other thing, and modifying the oil pan and the oil pump pickup are more things that need a bit of welding. So modifying the oil pan is not a big deal, and it's something that has to be done. So off camera, I went ahead and removed the oil pan from the engine just to get an idea what's down below. And it looks like the oil pump pickup is gathering oil mid-engine. That's going to be a problem, but not a huge problem. And we'll have to modify the pickup so it's grabbing oil from the back of the engine. The parts have been ordered for this modification, and we'll deal with it when the parts arrive. Now over on the bench, I have a sacrificial oil pan from a Volkswagen Rabbit. This oil pan was about $30 and I'm okay with cutting it up willy-nilly in order to gain enough space to clear the suspension crossmember. As you can see, I've already marked the pan with a few cut lines. Now the goal right now is to knock off enough material to get the engine to sit in the chassis so we can fabricate the motor mounts. Once the motor mounts are built and the engine is firmly mounted to the chassis, then we can fine-tune the shape of the oil pan, including adding a deeper sump. The safety tip for the day: always check the cutting disc on your angle grinder. Now, I'm not sure, but at some point last week, this grinder must have fallen on the floor and it did some damage to the disc. I have no idea what would have happened if I turned this thing on with a broken disc, but it wouldn't have been good. Anyway, the good news is I always wear a full face mask when using this thing. The modified oil pan was installed on the engine, and as you can see, the oil pump pickup is right on the edge and not fitting. The bad news is the oil pan will need to be chopped a little bit more, and that's going to guarantee the pickup's not going to fit. No worries, we can modify the pickup so it draws oil from the rear of the engine, and while we're at it, we'll extend the oil pan downwards to make up for the lost volume. Right now, this is the basic shape of the pan, and it'll allow the engine to fit in the chassis approximately where we want it to be. Fast forward and the engine is sitting in the truck again. We set the height of the crankshaft to 21 inches above the floor, and we're going to try to maintain this dimension as we fabricate the new motor mounts. As you can see, the oil pan clears the cross member, but the bottom of the pan is still way too close. This is definitely good enough for today, and once the engine is sitting on its mounts, then we can continue modifying the oil pan. So the first mount that we're going to fabricate will be on the right side of the engine, and we're going to be using the stock Chevy motor mount along with the bracket that was previously attached to the Iron Duke engine. Now, for some folks, this may not look like a perfect fit, but for me, I can connect the dots, and this is going to be a very nice fit, and this side of the engine is going to be a breeze to fabricate. Basically, all we need to do is fabricate a steel plate that attaches to the engine block, and then we can bolt the Chevy mount to the plate. Easy peasy. So this is the 1/4 inch thick steel plate that we intend on using, and I've already marked out the locations for the 4 holes that we'll need to drill in order to attach this plate to the engine block. Once we drill and cut this plate to size, then we can transfer the Chevy motor mount bolts to it. Oh, and we're going to need a few spacers, so I fired up the lathe and cranked out what we needed. And this is the finished motor mount system for the right side of the engine. The Iron Duke bracket needed a slight trim, and that was pretty much it. Let's install this stuff and see how it fits. Now, at this point in the game, we're still test fitting parts, and I may or may not use the correct fasteners, or I might not even torque the bolts down. No worries, when we do the final assembly, I'll use the correct fasteners and I'll tighten all the bolts. So for YouTube videos, I paint all my fabricated parts this gray color because it's easy to see on camera. Later on in the project, all the custom parts will get painted black to blend in a little bit better, but for now, they remain gray. So using the stock Chevy motor mounts is a bit of a compromise. They're certainly strong enough to hold the engine in place, but they're also very stiff and they may not be ideal to absorb the vibrations of the diesel engine. It's a tough call. The good news is the cab of the truck has rubber body mounts, and that should help isolate the angry diesel engine's vibrations from reaching the occupants in the cab. We'll find out soon enough. So this first generation Chevy S10 was produced between 1982 and 1993. This truck is physically smaller than the second generation S10 that came out in 1994. However, the frame is the same and the only difference is the location of the body mounts. So doing this swap on a slightly wider second gen S10 would be about the same. Now, I like the way the first generation S10 looks, and the first gen is actually not as heavy as the second gen. Okay, the mount is installed. Now on the first generation Chevy S10, the bolts that go through the frame require a nut on the other side. And for this top bolt, you can use an extension that'll pass through the spring and allow you to install the nut. However, to install the nut for the bottom bolt, you have to remove the spring and the lower control arm. It's kind of stupid the way they did this. So, a lot of folks drill access holes in the frame so you can get to the nut without taking the suspension apart. And as you can see, this truck has the holes in the frame. I drilled these holes when I took the original engine out because there was no way I was going to take the suspension apart just to gain access to the nut holding the engine mount in place. Anyway, the engine is still being supported by the cherry picker, and that's why there's still some space between the frame and the engine mount. Not too shabby. This side of the engine was super simple to fabricate the motor mount for, and it only took a few scraps of metal to build. Let's go ahead and move on to the other side. So this side of the engine is going to be a lot harder because there's a bunch of stuff that gets in the way. So let's start building a plan. First of all, this hole and this hole are available for part of the motor mount system. Now, right over here is where the dipstick goes, and obviously we can't build anything that'll block access to the dipstick. Now, over here we have this thingy for the coolant bypass hose. This guy is an important part, and we need to leave room for the hose to exist in its own space. Now, down here we have yet another thingy, and this is the feed for the heater core. We could block this guy off, but I want a heater that functions properly, so we're going to need to allow access for a hose connection to this thingy. The good news is we have two more bolts that pass through the water pump housing, and these bolts screw into a reinforced area on the engine block. So the plan is to use a 1/4 inch thick steel plate and build a bridge across the forbidden zone, and then we can build yet another bracket that attaches to these two lugs, and we can bolt the whole thing together. Once we have a solid bridge constructed, then I can weld two short outriggers to the steel plate, and those will attach directly to the stock Chevy motor mounts. This motor mount bracket system needs to be built in two pieces because the angle of these bolts are different than the angle of these bolts. It's a complex shape, but we can easily make it if we split it in two parts. Let me build this thing and you can get a better idea what I'm talking about. Anyway, the stock Chevy motor mount sits here, and it's definitely going to be a tight fit, but it's going to fit. And we're done. This pile of parts is the solution for the left side of the engine when using a stock Chevy motor mount. This guy is a thermostat housing extension for some sort of unknown Volkswagen, and it was $14 on Amazon. Not too bad. Anyway, we'll have to cut it right here, and this will provide an unobstructed connection point for the lower radiator hose. This is the bridge with the two outriggers welded on, and this is the secondary anchor point for the bridge. Let's see how it all fits together. The anchor bracket gets mounted to the engine block first, and once the bracket's in place, we still have access for the dipstick right here, so that's not going to be a problem. Also, the all-important coolant bypass hose still fits. Now, this is actually not the correct hose, and I need to source the correct hose for this engine, but this one would work. So the thermostat water neck that connects to the water pump housing is a tight fit. Let me take the water pump housing off to show you what I'm talking about. So this is the modified water neck that's mounted to the housing, and it allows us to attach a radiator hose so it points towards the radiator. I still have to trim this guy a little bit more on the belt sander to remove this angle, but for now it's fine. Let's install all this junk and see how it fits. Okay, so this spacer is supposed to go here, but it doesn't. I'll have to figure out what's going on off camera. You know, stuff like this only happens when the camera's running. Anyway, the bolts for the motor mount to the frame drop right in, so at least that worked out. And finally, the motor mount is in. Now the radiator hose gets real close to the steering linkage, but that's not a problem. This hose can be trimmed for a better fit. This is actually just some random hose I had for demonstration purposes. Let's go ahead and release the cherry picker and let the weight of the engine finally rest onto the chassis. And that's it, the engine's installed. It looks like the engine is tilting a little bit towards the driver's side. I need to check everything with the level, and if the engine's tilting, it may be okay, but it wouldn't be a big deal to fabricate another bridge bracket for the left side of the engine to correct the angle. Now, I'm not being super picky, but if the engine is tilting, then that's much needed space that I can recover with just a new bracket. You know, every little millimeter counts. Anyway, the most important thing is we have a solution for the left side motor mount that keeps the shifter happy, the oil filter happy, the dipstick happy, the drive shaft happy, the coolant bypass hose happy, and the water neck happy. This guy is still a problem, but that can be fixed with a welder, a grinder, and some more metal. So far, so good. Now, the engine in a Chevy S10 is not centered in the chassis, and it's offset to the right about a ½ inch or so. It looks like we may be a little bit more than that right now, and I need to wiggle stuff around to see if I can get it in alignment. And if it is truly off, that's no big deal. I can shim the right side of the motor mount a little bit to get the engine where it should be. But according to my initial measurements, it should be right or close enough. Again, I'm not being picky because I want to be. You see, this engine's a tight fit, and before I begin fabricating the oil pan, I need stuff to be as close to perfect as possible. I think for today we got it really close, and for the most part it was easy peasy. Now, for a lot of the popular engine swaps, you can purchase the parts that have already been engineered to fit. In our case, we have to figure everything out, then build the parts we need and see how it all fits. The good news is, we may have actually got close enough on our first attempt, and all we really need to do is a few adjustments to be spot on. Not bad at all. Now I'm really starting to look forward to hanging the intake and exhaust manifold on the engine. So despite this being a diesel engine, it actually has a lot in common with the gasoline engine that Volkswagen offered back in the day. For the most part, this engine looks identical to the gasoline version. The good news is the intake and exhaust ports on the diesel engine are also identical to the gasoline engine, and that really opens up a lot of options. The exhaust manifold that came with this engine looks like this. And while it's not terrible, it's not great either. It's an awkward fit. Now, you can't really get the whole story because the starter is not installed, but the exhaust manifold does come real close to the starter, which further complicates things. You know, I could make this manifold work, but it's just not worth the effort. So, we picked up a turbo manifold that was made for the Volkswagen engine, but I'm not sure if it's for a gasoline or a diesel engine. It really doesn't matter. It fits just fine. This exhaust manifold opens up a lot of space either with or without a turbo installed, so this is definitely the direction we're going. This manifold was sourced from eBay for $95 with free shipping, so it's not a bad deal in my opinion, and it looks like it's going to get the job done, especially on this unique application. Now, the intake manifold that came with this engine is nothing more than 4 pipes that go from the cylinder head to an air box. This manifold would work if we kept the engine normally aspirated, but it won't work with forced induction. So we're going to ditch this manifold, and we're going to use a manifold from a gasoline-powered Volkswagen Jetta. Now, what's nice about this manifold is the air intake is on the front of the manifold. Typically, on a lot of Volkswagen engines, the intake is on this side of the manifold, which obviously won't work in this truck application. Now, most of you folks already know this, but a diesel engine doesn't have a conventional throttle, and the only thing that goes here is the connection to the air filter or the boost pipe. There's no throttle body needed on this manifold. Not that it matters, but I kinda like the way this manifold looks. Of course, I need to clean it up so it's fresh aluminum again, but once it's all spiffy, it should look a lot nicer. Now, this guy was also purchased on eBay for a mere $60 with free shipping. So as most of you folks know, this channel doesn't generate a lot of revenue, and we have to keep costs down in order to continue making interesting videos. You know, I value the time and the intellect of my viewers, and I don't do sponsored videos like a lot of other channels do. So I shop around for bargains just like everybody else does. Anyway, the only real issue is it comes in contact with the heater box. That's not a big deal, and the heater box can be modified to provide the clearance that we need. So for the most part, we have the manifold situation under control. We'll have to do this, that, and the other thing to make all this stuff work, but none of it's difficult at all. Just another day in the robot Cantina workshop. Now, on this side of the engine, there's actually a lot going on that you don't see. Right now, we don't have the fuel injector pump installed, and it takes up a lot of space on the upper half of the engine. So this engine compartment is going to start filling up real fast once we install all the gizmos to make this engine run. The good news is the engine compartment compartment is huge, and no matter what we do, this engine's going to look real small, and that's because it is kind of small. With a little bit of engineering and some scrap metal, we were able to fabricate all the parts that we needed to mount the diesel engine in the chassis of the pickup truck. It's amazing, but the only thing we purchased on this table was this guy, and it was $14. The rest of the stuff was built in our workshop in one afternoon with a grinder, a welder, and a lathe. You know, if this diesel-powered square-body 1989 Chevy S10 pickup truck interests you, then consider subscribing to the channel if you haven't done so already. I know last week we picked up a few more subscribers, and the more subscribers that we have, the faster we can grow the channel. This is actually a pretty big project, and we started with a rusted-out Chevy that was on its way to the scrapyard, and we're giving it a new life by rebuilding it into something that's, well, nothing special, other than a fuel-efficient, practical small pickup truck that you can't buy new these days. Anyway, I'm Jimbo, I'm a real human, and we'll see you next time. Until then.